एस्टिमेशन ऑफ सीरम इलेक्ट्रोलाइट, चैप्टर नंबर 34। आज हम लोग समझेंगे इलेक्ट्रोलाइट का एस्टिमेशन हम लोग कैसे करेंगे और इलेक्ट्रोलाइट का एस्टिमेशन कब इम्पोर्टेंट होता है, कौन सी डिजीज़ में इलेक्ट्रोलाइट चेक किया जाता है। तो चलिए शुरू करते हैं। पहला है फ्लेम फोटोमेट्री। सोडियम एंड पोटेशियम इन ब्लड एंड बॉडी फ्लूइड्स आर यूजुअली मेजर्ड बाय flame photometry. The test solutions containing these elements are passed as fine spray into a non-luminous flame, which becomes colored by the characteristic emission of the metal. This emitted light is then passed through suitable color filters to remove lights other than this emitted light, which then falls on a photosensitive element. The amount of current produced by the photosensitive element is measured with the help of galvanometer. The current varies with the amount of sodium or potassium present. तो क्या कह रहे हैं, फ्लेम फोटोमेट्री से हम लोग सोडियम, पोटेशियम और क्लोराइड, तीन चीज़ होता है इलेक्ट्रोलाइट में, सोडियम, पोटेशियम और क्लोराइड, इसका एस्टिमेशन हम लोग करते हैं। तो कैसे करते हैं, आपने देखा कि सोडियम, पोटेशियम जो ब्लड में रहता है बॉडी फ्लूइड्स में, उसको हम लोग फ्लेम फोटोमेट्री से मेजर करते हैं और टेस्ट सोल्यूशन जो ये सब एलिमेंट कंटेन करता है उसको हम लोग फाइन स्प्रे से पास करते हैं, जो कि नॉन इल्यूमिनस फ्लेम होता है और ये जो है कलरफुल सब्सटेंस में चेंज हो जाता है, जो कि कैरेक्टरिस्टिक्स है उस मेटल का। सोडियम मेटल है, पोटेशियम मेटल है, तो इसका और ये जो इमिटेड लाइट है फिर इसको कलर फिल्टर से पास करते हैं ताकि जो दूसरी लाइट्स हैं उसको रिमूव किया जा सके। उसके बाद फोटो सेंसिटिव एलिमेंट में डालते हैं और उसके बाद गैल्वेनोमीटर से हम लोग करंट मेज़र करते हैं और करंट का अमाउंट जो है वो अमाउंट ऑफ मेटल पे डिपेंड करेगा। तो करंट वेरीज विद द अमाउंट ऑफ सोडियम और पोटेशियम प्रेजेंट। ओके, द सीरम और प्लाज्मा इज डाइल्यूटेड सुटेबली विथ डीआयोनाइज्ड वाटर। सीरम और प्लाज्मा को पहले डाइल्यूट करते हैं, किससे, तो डीआयोनाइज्ड वाटर से और डबल डिस्टिल्ड वाटर से। द डाइल्यूटेड सैंपल इज फर्स्ट स्प्रेड एंड द रीडिंग ऑन द गैल्वेनोमीटर इज नोटेड। Immediately after two standard solution, one more and another less concentrated than the test sample are sprayed and their readings noted. Calculation is made in the following ways. For example, reading of test sample for potassium is equal to 44. Reading of standard containing 4 milliequivalent per liter potassium 38. Reading of standard containing 5 milliequivalent per liter potassium is equal to 50. तो 44, 38, 6 डिफरेंस रीडिंग 6 और 50, 12, 38, 50, 12. The amount of potassium in test sample is equal to 4 plus 6 upon 12 into 1, 4.5 milliequivalent per liter. Nowadays instruments directly give reading of sodium and potassium. Reagent. पहला distilled water. If the distilled water contains even trace of sodium or potassium, appreciable error will be caused. Double distill. All gas distillation is good. Ordinary distilled water can be effectively purified by passing it through column of suitable ion exchanger. A stock sodium solution 200 milliequivalent per liter, 11.69 gram of pure dry sodium chloride per liter in water. Third, stock potassium solution 10 milliequivalent per liter, 0.746 gram of pure dry potassium chloride per liter in water. 1 लीटर में 0.746 ग्राम प्योर ड्राई पोटेशियम क्लोराइड लेना और 11.69 ग्राम ऑफ प्योर ड्राई सोडियम क्लोराइड लेना 1 लीटर में। वर्किंग स्टैंडर्ड कंटेनिंग बोथ सोडियम एंड पोटेशियम। इट इज़ कन्वीनियंट टू मेक combined working standard for both sodium and potassium. The presence of both elements in the standard compensate for the interference of one element with the other in the diluted plasma. Into 1000 ml volumetric flask, measure the volume of stock sodium and potassium given in the following table, and then make to mark with water. Mix well and keep in polythene bottle. Working standard 1. Stock sodium 5.5, stock potassium 1, sodium equivalent in serum 110, potassium equivalent in serum milliequivalent per liter 1. Working standard 2. Stock sodium 6.0, stock potassium 2, sodium equivalent in serum milliequivalent 120, potassium equivalent in serum 2. Working standard 3. Stock sodium 6.5, stock potassium 3, sodium equivalent in serum milliequivalent 130, potassium equivalent in serum 4. Five 7.5, 150, 6 8.0, 160, 7 8.5, 170, 8 9.0, 180. Procedure. All glassware should be finely rinsed with deionized or glass distilled water and dried in oven. 3 ml venous blood is collected with a dry syringe. The blood can be put in a clean and dry test tube or in tube containing lithium heparin or calcium heparin and mixed gently. The serum or plasma blood should be separated as early as possible to prevent leakage of intracellular potassium. Care should be taken to avoid hemolysis. Serum is diluted 100 times. 0.1 ml serum is added to some distilled water in a 10 ml flask. The volume made to mark with water and mixed well. 0.1 ml serum is added to some distilled water in 10 ml flask. The volume made to mark with water and mixed well. The flame photometer is run according to the direction given by the manufacturer. The instrument is connected to an air compressor and to LPG cylinder. The compressor is switched on and the pressure of air passing through the instrument is adjusted to 10 lb per square in 0.7 kg square centimeter. Then gas tap is opened and the burner is lighted. The flame is so adjusted that the cones seen in the flame are discreted and not fusing with one another. The flame should be non-luminous. The suction tube is dipped in distilled water. Water is sucked and sprayed into the flame. The suction tube is dipped in distilled water. The flame is so adjusted that the cones seen in the flame are discrete and not fusing with one another. The flame should be non-luminous. The suction tube is dipped in distilled water. Water is sucked and sprayed into the flame. It may be necessary to read just the flame again. The galvanometer is switched on. Put the filter of sodium in the right place. The water should not make the flame luminous. If it does, most probably the water contains sodium or other metal ions. Such water should not be used. While the water is being soaked, bring the galvanometer reading to 0 by turning 0 adjuster. Now replace water by a standard number 8. The needle is deflected. Bring the needle to read 100 with the help of sensitivity control. Replace the standard by water and readjust the needle to 0 by 0 adjuster. Recheck with a standard number 8. The instrument is now ready for use. Diluted serum is then allowed to be sprayed and the reading on the galvanometer is noted. The suitable standard, one of which should give closely lower reading and another higher reading. Then the tests are similarly sprayed and their readings noted. The calculation is done as mentioned above. If potassium has also to be determined, then replace the sodium filter by potassium filter and then proceed as described above. Also, flame photometers which read both sodium and potassium simultaneously are available. In such instrument, emitted ray of light are split, one portion passing through sodium filter and another through potassium filter. Some manufacturers also provide filters for estimation of calcium and lithium. Sodium, potassium and calcium can also be estimated by electrolyte analyzer which use ion selective electrode to measure potential difference between a specific ion selective electrode and a reference electrode. Second, ion selective electrode ISE. Electrolyte analysis by flame photometry is a time consuming and cumbersome method. Also, one has to be careful as we are using a gas flame during the analysis. A faster and easier method of analyzing is by using the ISE electrolyte analyzer, ion selective electrolyte analyzer. An ion selective electrode ISE makes use of the unique properties of certain membrane material to develop an electrical potential electromotive force for the measurement of ions in solution. The electrode has a selective membrane in contact with both the test solutions and an internal filing solution. The internal filing solution contains the test ion at a fixed concentration. The electrode has a selective membrane in contact with both the test solution and an internal filing solution. The internal filing solution contains the test ion at a fixed concentration. Because of the particular nature of the membrane, the test ions will closely associate with the membrane on each side. The membrane EMF is determined by the difference in concentration of the test ions in the test solution and the internal filing solution. The voltage generated is theoretically dependent on the logarithm of the ion activity. According to the Nernst equation, the complete measurement system for a particular ion includes the ISE, a reference electrode, and electronic circuits to measure and process the EMF to give the test ion concentration. The sodium and potassium electrode are based on neutral carrier and the chloride electrode is based on an ion exchanger. In the ISE analyzer, there are separate electrodes for the ions that we wish to measure: sodium, potassium, calcium, chloride, etc., and a reference electrode. ISE electrolyte analyzer, और ये है ISE electrodes. The ISE analyzer also has some drawback, like it requires frequent recalibration of the instrument before and may be during the run. The electrode have a fixed life, they have to be replaced. Clinical interpretation: serum sodium hypernatremia. Serum sodium hypernatremia: increased serum sodium concentration, inappropriate parenteral therapy with saline solution, inappropriate parenteral therapy with saline solution. Second, high salt intake without corresponding intake of water. High salt intake without corresponding intake of water. Hyperaldosteronism. Cushing syndrome: increased level of mineral corticoids causes increased tubular reabsorption of sodium. Increased production of ADH or decreased tubular sensitivity to ADH. Osmotic diuresis. Hyponatremia: in decreased serum sodium concentration. Salt losing enteropathies. Malnutrition: salt water dehydration or primary salt depletion, as in excessive sweating or persistent diarrhea. Salt losing enteropathies, malnutrition, salt water dehydration or primary salt depletion, as in excessive sweating or persistent diarrhea. हाइपोनेट्रेमिया यानी कि सोडियम सीरम डिक्रीज हो जाएगा, डिक्रीज सीरम सोडियम कंसंट्रेशन. तो साल्ट लूजिंग इंटेरोपैथीज, malnutrition, salt water dehydration or primary salt depletion, as in excessive sweating or persistent diarrhea. 4. Addison's disease, primary adrenal insufficiency leading to deficient aldosterone production. 5th, ascites from congestive cardiac failure, CCF. 6. Nephrotic syndrome. And 7th, syndrome of inappropriate antidiuretic hormone secretion. Serum potassium. Hyperkalemia, increased serum potassium concentration. Dehydration, severe burns or shock. Violent muscular activity, massive intracorporeal hemolysis. Decreased excretion of potassium in acute renal failure or end-stage renal failure. Addison's disease and in adrenocortical insufficiency. हाइपरकैलेमिया कब होता है? इंक्रीज सीरम पोटेशियम कंसंट्रेशन, तो डिहाइड्रेशन में, सीवियर बर्न या फिर शॉक, वायलेंट मस्कुलर एक्टिविटी, मैसिव इंट्राकॉर्पोरल हेमोलाइसिस, decreased excretion of potassium in acute renal failure or end-stage renal failure, Addison's disease and in adrenocortical insufficiency. Hypokalemia, decreased serum potassium concentration. hypokalemia, decreased serum potassium concentration, starvation, post-operative therapy with potassium poor fluid, institution of insulin therapy for diabetic hyperglycemia results in cellular glucose uptake accompanied by potassium uptake, alkalosis, potassium move from ECF extracellular fluid to the cell and hydrogen plus moves in the opposite direction, gastrointestinal losses as in vomiting and diarrhea, Cushing's syndrome, hyperaldosteronism. Question and answer. What is the normal serum or blood chloride level? The normal value of serum chloride is 95 to 105 milliequivalent per liter. What is the function of chloride ions in the body? The function are first being the major anion of the body. Chloride along with sodium helps maintain the osmotic pressure of the extracellular fluid, helps in the maintenance of the pH of the blood. Chloride shift and third, involved in the formation of HCl in the stomach. Fourth, activates the enzyme salivary amylase. तो इतना सारा काम है. Function are first being the major anion of the body. Chloride along with sodium helps maintain the osmotic pressure of the extracellular fluid. Second, helps in the maintenance of the pH of the blood. Chloride shift or third, involves in the formation of HCl in the stomach. And fourth, activates the enzyme salivary amylase. Question 3. Why is there hypochloremia in case of excessive vomit? Answer. During vomiting, all the gastric content are expelled out. HCl is secreted by the stomach cells and is also expelled out, especially during excessive vomiting. This leads to low level of chloride in the blood. Question number 4. What are the causes of hypochloremia? Hypochloremia is seen in case of first, excessive vomiting, second, respiratory alkalosis, third, salt-losing nephritis, chronic pyelonephritis, fourth, addition disease, fifth, metabolic acidosis, diabetic ketoacidosis, renal failure and SIADS, prolonged gastric suction. Question 5th. Enumerate the causes of hyperchloremia. The causes of hyperchloremia is first, extremely high dietary intake of salt, over treatment with IV saline, dehydration causing Cushing syndrome, severe diarrhea, respiratory acidosis and renal tubular acidosis. Why does the serum chloride level decreases and urinary chloride level increases in case of Addison's disease? In Addison's disease, the mineralocorticoid depletion causes impaired reabsorption of chloride from the renal tubules. This leads to passing out of chloride into the urine. What is chloride shift to where does it occur? The chloride shift is seen in RBC. The RBCs because of lack of aerobic pathway do not generate a large amount of CO2. Plasma CO2 diffuses into RBC along a concentration gradient. Here it generates bicarbonate ions through the carbonic dehydratase system. H+ generated by this system is buffered by hemoglobin. As the concentration of intracellular HCO3 rises, it diffuses into the extracellular fluid along the concentration gradient. To maintain the electroneutrality, chloride ion diffuses into the cell. This is known as chloride shift. Okay friends, ये चैप्टर कंप्लीट हो चुका है. नेक्स्ट है चैप्टर 35, ब्लड गैस एनालिसिस यूजिंग ABG एनालाइजर. तो मिलते हैं नेक्स्ट वीडियो में. तब तक के लिए बाय. हंसते रहिए, मुस्कुराते रहिए और पढ़ाई करते रहिए. बाय बाय.